Okay, so quadrilateral EFGH. The coordinates are listed right there, and we need to go and figure out what that is. So I'm going to scoot over here. Say that there. Okay. Where I have written these out, notice I go from, let me make this bigger, from E to F to G to H, okay, around this particular quadrilateral. I'm going to tell you this is the second time that I've videoed it, because the first time I actually went from E to F, and then I put G here, and then H, and nothing works out correctly when you do that. It's very important that you always, when the picture is described to you rather than actually shown, you have to make sure that you drop those points in order. It doesn't matter whether you go clockwise or counterclockwise. Just make sure you drop them in the order that they're told to you in the quadrilateral. Okay. Alphabetical is not important. Usually that's how I will give them to you, but that's just not important in terms of how you drop these points off around the quadrilateral. So looking at this, you can see I made a crude model of it. Didn't graph it like I did on number 1, because I want to show you it's really not necessary to graph it as long as you know that you've written it correctly according to the order of the points. Okay, so the slope, I'm going to go from E to F and calculate the slope. Remember, the y's go on top, so I do it rather than writing it like this, -2 minus 2 over -3 minus -2. That's just takes longer. And I do it by imagining jumping up and down the number line. So if I start at -2 and I end at 2 on the number line, I went up 4. And if I start at -3 and end at -2, I went up 1. So that's how I know that the slope for EF is 4. Okay, now I'm going to go this way. If I start at the y value of 2 and end at the y value of 2, I went none. Okay, then if I start at -2 and end at 3, I went up 5. 0 over 5 is 0. So there is, I know that actually, even though I've got it drawn vertically, a slope of 0 is a horizontal. So I know that I've drawn it, not correctly, but it doesn't really matter as long as I've got them in order. So now I'm going from here to here. From 2 to -2, I went down 4. And from 3 to 4, I went up 1. So the slope here is -4. Okay. One interesting thing when I first see this 4 -4, I think, oh gosh, I always double check my signs, because I was hoping that the opposite slopes were the same, and they're not. But I can see I went up 4, and then from -3 to -2, that was up 1. That's positive, definitely. -2 to 2 is up 4, and then, or sorry, 2 to -2 is down 4, and then 3 to 4 is up 1. Yeah, they're definitely just opposite. Opposite slopes are just not the same. They just look similar. Lastly, from here to here, -2 to -2, I went up 0. And from 4 to -3, I went down 7. So the slope here is 0 also. All right, what that means is that this side here and this side here, EH and EF, those are parallel. Whenever you've got what is definitely, and you can go in here and mark, let's just look at what the question said again. Opposite sides are not parallel, so it's not a parallelogram, which means it cannot be a rectangle, rhombus, or square, since all of those are subsets of the set of all parallelograms. It is definitely a trapezoid, because I have one set of parallel sides. Now let's look at if it is an isosceles trapezoid. For isosceles trapezoid, you've got to have the two non-parallel sides the same. I'm looking to see, is that true about the two sides? And to figure out if they are, I've got to use the distance formula. So I'm going to write it out. Remember, to remember the distance formula, I use what looks like how many licks does it take to get to the center of a Tootsie Roll Pop owl? Okay, now pick up my x's, -3, -2. Doesn't matter if you do x's first or y's, you just have to do them together because it's plus in the middle, and that's commutative. From -2, here I'm going to put -2 and 2 in there. All right, so -3 minus a -2 is the same as -3 plus 2, which is -1. I'm going to go ahead and square it to save room. That's 1 plus Negative 2 minus 2 is negative 4. When you square that quantity, it's a positive 16. So this length is the square root of 17. I'm just going to highlight them alike so that I can see what's what. Okay. Next, I'm going to do the distance formula between h and g. Okay. Put in my x's, the 4 and the 3. Put in my y's, the negative 2 and 2. 4 minus 3, that is a 1. Quantity squared is 1. Plus negative 2 minus 2 is negative 4. When you square that quantity, it is 16. And the square root of 16, or sorry, the square root of 1 plus 16 is the same as the square root of 17. So this segment there and is that length, which means the two are, in fact, what I was looking for. They are parallel. They are congruent. That and that, which means it's not just a trapezoid, it's also an isosceles trapezoid, which means that that one's not right. Okay? And so the answers to 2 are E and F.